Hello, Algebra 1 students, and welcome to Lesson 5 on our first unit. This lesson, I actually decided to break it down into two different parts, just because I felt like it was going to be too long of a video, and it was really spanning just a lot of different topics. So we're just going to take a look at part 1 for today, and our assignment then will reflect that when we get into that and we're practicing the things. So our objective is I can simplify expressions containing roots. So we're going to be talking about square roots and different types of roots. So first we'll go through and review square roots, and we'll talk about three examples on square roots. So I'm just going to change up my pen here, and we'll go ahead and get started. Alrighty, so this is a lot on here. So we'll just kind of pick and choose some things or go through and look at it. So it says a number that is multiplied by itself to form a product is a square root of the product. Then you've got the radical sign square root is used to represent your square root. For non-negative numbers, the operation of squaring and finding a square root or inverse operations. So a square root and squaring something are inverse operations. Basically, that's a big part of this. So say, for instance, let's take, 4 squared. All right, well, if I did 4 squared and I found what 4 squared is, it is 16. Basically, if I want to undo that or inverse it, I use my square root sign. I find what times what gave me 16. 4 times 4, so your answer for the square root of 16 is 4. All right, says positive real numbers have 2 square roots, which means that you can have a negative and a positive, because think about this. If you had it with the parentheses now, you had negative 4 squared, it's still going to be a positive 16. So it's a given that you'll have the positive and the negative answer. So it says the principal square root of a number is the positive square root and is represented by this. So if they just show you a square root symbol and 16, it's just going to be the positive version. But sometimes if they want the negative version, they'll show that symbol out in front of that square root radical sign, or they'll show both a positive and a negative. I didn't even realize I gave the same representation here. But they showed that to basically my problem over here. And showing that, yeah, the negative would be the same thing. But if you wanted it to actually show a negative 4 as an answer, you'd have to keep the negative sign out of the radical symbol here. Okay, I know that was a lot to take, or you can always pause it, write down a few notes as you go through. But for the most part, if it's got a radical sign, assume that your answer is going to be positive unless it's got a symbol on the outside. So it says a perfect square is a number whose positive square roots is a whole number. Some examples of perfect squares are shown in the table. So remember, it's just squaring. It's going to be that perfect number. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So that's where this is a perfect square. It can easily just find our one number and so on. A number that is then raised to the 3rd power, we call it a cube root. And so this one's a little different because the square root, we need to assume we're getting rid of the squares. But if you have a cube root, it has the same radical sign, but it'll have a 3 next to it. Okay, so that means you want to find what number times that number would give you that number. So for instance, you had 4 times 4 times 4. Which is 56, I believe. I hope I'm doing this right. 4 times 4 times 4. No, 54. And you would want to solve it under here. And so they continue on talking about then your other roots. So if you had a root of 4 and you wanted to find the inverse operation of putting it to the 4th, you can then, I don't know how you'd say this other than taking the 4th root. I guess you'd say 4th root, 5th root, so on. So let's take a look at a couple of these examples then. I think it'll get a little more easier once you get into some examples. So example 1 is finding roots. Find each root. So when I actually do roots on my computer, it doesn't take into account pulling out this, you know, the sign above here. So just assume that that's kind of what it does. But I'm going to take the square root of 49. So if I want to think about that, I think I got to think what number times itself would give you 49. Well, I'd maybe start with 5. 5 times 5 is 25. 6 times 6 is 36. 7 times 7, oh, that is 49. And since there was no symbol out in front of it, I'm going to assume that it's the positive version of that number. This time now I do have the negative, so whatever my solution is, I'm actually going to have the negative value of what is under here. So I got to think what times what gives me 36. Again, I kind of went through this just a sec ago, and 6 times 6 gives me 36. The negative sign's outside, so I have negative 6. All right. And this last one is a cube root, so I have to think what number to the third would give me negative 125. Negative 125. That kind of stumped me for a minute because I was like, you can't do negatives in a square root, but you can have negatives under the radical sign if they're cubed or if they're an odd power. Because remember, you can have an actual negative answer. You can't have a negative answer for square root, so that's why you should only see it underneath, or sorry, outside of the radical and not underneath it. If you see it underneath it, you can't actually solve it. Well, I know that 5 times 5 times 5 is to the power of 3. So I would say that my answer is negative 5, or you could write it as negative 5 in that parentheses. All right. So negative 5 to the third gives you a negative 125, and that's how I could find the cube root of negative 125. So let's look then at finding roots of fractions. So here's the tricky part of taking a root of a fraction. So I'm actually going to write this a little nicer so it's easier. So as you can see, you've got a numerator and a denominator, and I've got to take the square root of this. So what it really is asking me to do is take the square root of 1 and take the square root of 8 or 4. Okay? So basically, what I did is I just took I took this giant square root and I put it on the numerator and the denominator. And so then I can just worry about what number is on the top of the fraction and what's on the bottom of the fraction. Well, your square root of 1 is 1. 1 times 1 is 1. And then your square root of 4, well, I got to think what number times itself will give me 4. 1 times 1 is 1. 2 times 2, yeah, that is 4. So my square root of 1/4 is 1/2. So anytime you have fractions, take it by the numerator and then the denominator. So break it up. Bring up that radical to the numerator and this the denominator. And then do those numbers separately and keep them in that fraction form, if they stay in a fraction form, that is. Alrighty, let's continue on. Says square roots of numbers are not perfect squares, such as 15 are not whole numbers. A calculator can approximate the value of the square root of 15 as 3.872983346. Oh my god, that's a lot. Without a calculator, you can use the square root of perfect squares to help you estimate the square root of other numbers. So they're talking about the fact that, like, okay, so let's look at that chart again. So these are all your perfect squares. Well, the square root of 15 would land in between 3, or the square root of, or so 9 and 16, because that's your actual answers. But remember, when we take the square root, we want to know what's that number that would be the base. So it'd be somewhere between 3 and 4, and closer to 4, so maybe it would be like 4.9. Oh, sorry, 3.9. You want between 3 and 4, so you can't go because that would be between. So yeah, so that's where you get that, yeah, 3.8, so on, as you go through. I think we've got just that one example left, and then the next part is going to be in another video. So your code word for this one, let's think of one. How about monkey? That's your code word. Monkey. Alrighty, so let's look at this example. So here's a gardening application. So if you're into gardening, I really would like to, but it takes a lot of work. It says Nancy wants to plant a square garden of wildflowers. She has enough wildflower seed to cover 19 feet squared. Estimate to the nearest tenth the side length of a square of an area of 19 feet. So she's making a little garden. Remember, your area is always feet squared. So if I wanted to find the area of this, she says it's 19 feet squared. So we are going to think, okay, so let's look at our table. 19, thinking about my perfect squares. Well, 19 would fall in between 16 and 25, right? Now, the question is, it's going to be closer to 4, so is it closer to 16 or is it closer to 25? Well, from 19 to 25, it's a distance of 6. From 16 to 19 is a distance of 3. So I'm figuring my solution will be probably pretty close to 4. Maybe thinking maybe like a 4.3. Let's test that out. Again, it's an estimation. So estimate the nearest tenth of the side length of a square. So we're thinking if we take the square root of 19, I'm going to say that it's maybe 4.3. I don't know yet. I'm going to test it with a calculator here, and I'm going to plug in 4.3 squared and see if I get 19. So I think my computer, or my calculator is actually here in my backpack still. Your phone ones can do that fancy stuff if you turn your phone to the side. But for this, I usually like to grab a calculator more so. All right, 4.3 squared gives me 18.49. So I'm pretty darn close. Let's see what 4.4 gives me. 4.4 squared. All right, 4.4 squared gives me 19.36. So I want to know which one's actually closer to 19. So if I were to take this one, well, I want it as close to 19 as I can. 19.36 minus 19. So it's off by 0.36. If I want to see how close 4.3 is, 0.4349, oops, minus 19.00. Ooh, I gotta carry everything over, don't I? All right. So for my calculation, when I go back and look at 19, 18.49 is 0.51 away from 19, and 19.36 is only 0.36 away from 19. So my closest answer, because they're asking me to nearest tenth, is going to be this one, which is then, remember, we don't need that square, so your answer would be 4.4. So that's how I can use estimation. As you saw, I kind of looked at, okay, well, 19 is in between the perfect squares of 16 and 25, which result in, if you square root those, 4 and 5. 19 is closer to 16, so I assume I'm going to have a decimal place closer to 4 than I would to 5. So that's why I started with this 4.3 just as a guess, and I went, okay, 4.3 squared and 4.4 squared, and then I decided which one's closer, and 4.4 is my closer solution, and so that's why I'm picking that as my closest solution. All right. Let me know if you've got any questions, but I will see you guys in the next video or the next actual live session before you move on to that second part, okay? So here's the first part for this lesson, which is all about your cube roots, and I will check you in the next one as we go into classifying real numbers. So have a good day. I will see you next time. Let me know if you have any questions. Feel free to go back through this video if you need to, or if you didn't catch that code word.